Welcome. Today we're going to talk about section 3.1, which is basically a review on solving linear equations. So I'm going to kind of start with some basic ones and move up to ones that are a little bit more complex. You will be required to show your work for both the equation and the check on all of your problems. So you may want to make sure that you know how to do the balance statements or the checks at least, if you do remember how to solve equations. So you can feel free to fast forward or to look through what you need for the video. So at the very top of the page, we have notes on solving equations. So these are my recommended steps for your ease in solving equations. So you can see these in the text in section 3.1 on Blackboard, or you can come back to this video and take notes on these. However you want to do it, just make sure that you are aware of the order of operations kind of when it comes to solving an equation. You're also welcome to use your calculators to help you with positives and negatives as we start working with some of the sign numbers in this as well. So we'll start off with a pretty basic equation where we just have 2 plus x is equal to 9. So we move everything away from the variable using its opposite sign here in this problem. So since it's a positive 2, we'll turn it into a negative 2, bring it over to the other side with its sign, cancel these out, keep our x, subtract, we have 7. So this is called our solution. Okay, so over here we're going to do the check, which I'm going to start with my original equation, 2 plus x is equal to 9, and I replace my variable with whatever my solution was, because that's what x is equal to. So we have 2 plus 7 now is equal to 9. So I'm going to simplify each side, and that's equal to 9, and that matches the other side. So as long as the two sides match when you're finished, you know that your equation was correct. Okay, so I expect to see this line and this line when you're doing your balance statements at minimum for your homework and your labs. Okay, here we've got y minus 3 is equal to 7, so that's a negative 3. So the opposite of a negative is a positive 3. So I'm going to make sure I bring that over. Make sure you carry your sign so you can see what you're supposed to do when you get to the other side. So y is equal to 10. So that's my solution. So I'm going to check it. So I have y minus 3 is equal to 7. That's a 3. I'm going to replace my y with a 10. So 10 minus 3 is equal to 7. 7 equals 7. Okay. Down here, I've got a different way that it's connected. So I have 4x is equal to 12. So 4x means 4 times x. And the opposite of multiplication is division. So we're going to divide both sides by that positive 4. We're not changing our signs in this case. The opposite of a positive 4 multiplied is a division by 4, not a negative 4. So here the opposite of negative was a positive, positive and negative. The opposite of multiplication is division. Okay, so we don't change signs when we divide. So we're going to keep our x. We'll divide 12 by 4. We get 3, our solution. And here I've got 4x is equal to 12. I'm going to place my x with the 3. Now this is 4 times x, so it's 4 times 3 is equal to 12. 4 times 3 is 12, and 12 is equal to 12, so I know that I have my correct solution. The last one on this page is negative 5y is equal to 25. Again, negative 5y means negative 5 times y. So we'll divide both sides by negative 5. We're dividing by whatever is in front of that variable. That's called the coefficient. So if it's positive, we divide by a positive. If it's negative, we divide by a negative. So these cancel out. I have my positive y, and my positive 25 divided by negative 5 is a negative 5. Again, you can use your calculators to double check your signs. So we'll start again at negative 5y is equal to 25. I'll replace my y with my negative 5. So negative 5 times negative 5 is a positive 25, which equals that positive 25 on the other side. So that checks out. Okay, let's look at the next examples. So this one sometimes gives people difficulty because we don't see it as often in some of our basic or linear equations. So this is saying x divided by 4 is equal to 7. So the opposite of division would be multiplication. So the reason I'm multiplying is, if I think about this as multiplying by 4 over 1, really those 4's would cancel out. So in multiplication, I'm still just canceling out my my coefficient through the opposite function. So I have my x here, and now I have 28. So to check it, I have x over 4 is equal to 7. So then I replace this x with my 28. So I now have 28 over 4 is equal to 7. And 28 divided by 4 is 7, which equals 7. So my check works just fine. Here it's x divided by a negative 6. So the opposite would be, again, to multiply by a negative 6. Okay, so those would cancel out, and I have my x. And whatever I do over here, I need to do over here. So I have x is equal to negative 48. So that would be my solution. So I'm going to go back and check it again. I have x over negative 6 is equal to 8. This x is going to be replaced by that negative 48. So I have negative 48 divided by negative 6 is equal to 8. Now that negative divided by a negative is going to give me a positive 8, which matches this positive 8 on the other side. Okay, for the next one, I have a multi-step equation. So I have a 2x plus 6 is equal to 12. I need to make sure that I'm moving my numbers away from the variable in a particular order. So you always move what we call the constant first, and that's the number that's alone without a variable. It's always got a positive or a negative sign with it. So I'm going to move the 6 first, and then I move the 2 last. I always move the number with the letter last. I don't want to move the 12 over because if I do, everything's on one side, and my goal is to get that variable alone. So since it's a positive, I'm going to make it into a negative 6 on both sides. This cancels. I have my 2x. I have 12 minus 6, which is 6. And now my next step, it's 2 times x, so the opposite is to divide by 2. So x would be equal to 3. Okay, that's my solution. So my check, again, I start with the original equation. I replace my variable with my solution. So it's going to be 2 times 3 plus 6 is equal to 12. Now, if you want to, I need to see this part right here, but if you want to use your calculator to simplify each side and then just give me the solution from there, that's fine. So this is 6 plus 6, that's 12, is equal to 12. So that's my complete check. I want to see all the way down to one number equals one number. Here, 18 is equal to negative 3 plus 7x. So I'm going to start by adding the 3 to both sides. So 18 plus 3 is going to give me 21, which is equal to 7x. And again, 7x is 7 times x. So I'm going to divide both sides by 7, and x would be equal to 3. Okay, so I've got my 18 is equal to negative 3 plus 7x. Replace that x with that 3. So 18 is equal to negative 3 plus 21. And when I subtract, I get 18, which matches the other side. Okay, so the next one has variables on both sides, and sometimes this trips people up a little. So let's go ahead, and my suggestions in my directions say to move a variable first. So you can move either the 6x or the 8x, and we're going to move them by addition or subtraction, whatever their opposite function would be. So I recommend usually moving the smaller of the two. You're going to get the same answer no matter what you do. However, if you move the smaller, you end up with a positive number, which a lot of people prefer. So I'm going to subtract the 6x from both sides. And again, if you move the 8, it's fine. This cancels and I have 5. And 8 minus 6 is going to give me 2x. And then I have a negative 3 that I need to bring down. Okay? So my next step would be to move this 3 over to the other side by using its opposite function. So I'm going to add 3 to both sides. This cancels. I have 2x. And over here, 5 plus 3 is going to give me 8. So my next step would be to divide that 2 times x. I'm going to break that apart by dividing by 2. And x would be equal to 4. So that's my solution. So the more you do, the more important a check is because you could have made a mistake. So this time I have 6x plus 5 is equal to 8x minus 3. Notice that I have x's in two positions. So this 4 needs to replace this x and this x, okay? So I've got 6 times 4 plus 5 is equal to 8 times 4 minus 3. So again, you could use a calculator to reduce each side or simplify each side, and then the numbers should match, or you can do it by hand. So this is 24 plus 5, which is 29. And over here, 8 times 4 is 32, minus 3, which is also 29. So it does check out for us again. Okay, so here's another one with two variables, or variables on each side. So we want to make sure, again, that we're moving one of the variables first. And you could move the 12x or the 7x, but I like to move the smaller. So I'm going to go ahead and move that 7x by subtracting it on both sides. So 12 minus 7 is going to give me 5x minus 8 is equal to negative 18. Okay, so then I'm going to add 8. And I have 5x is equal to negative 10. So watch your signs. Again, use your calculator if you need assistance. Divide by 5. So x equals a negative 2. Okay, so we're going to check this again. So I have 12x minus 8 equals 7x minus 18. I'm going to replace my x's, both of them, with a negative 2. So I have 12 times negative 2 minus 8 equals 7 times a negative 2. My pen's going out. Minus 18. Simplify each side. So this would be negative 24 minus 8. That's a negative 32. And on this side, you have negative 14 minus 18. So those get added together, which gives you a negative 32. So it checks out. Okay, so this next problem is going to require you to simplify first. So when you have parentheses, it might have been a while since you've last done problems like this. You take the number on the outside of the parentheses and you multiply it by every term on the inside of the parentheses. So we're doing 3 times a 1x, which is 3x. 3 times a positive 4 is a positive 12. Then we do the same thing but with a negative 2. Now watch your negatives. It's going to change your signs. So negative 2 times x is a negative 2x. Negative times a negative is a positive, and then we've got a 12. So right here, you've got to be careful about that negative times a negative on this. So in this case, I'm going to move my variables first. So this time I'll take this negative 2x and change it to a positive. Again, I'd much rather work with positives than negatives. So this cancels. I have 5x plus 12 is equal to 12. So I'm going to subtract. Remember, I got to move away from the variable, so I'm going to subtract 12 from both sides. I have 5x, and this is going to equal 0. So I'm not finished yet. I've still got to divide by 5, and x is equal to 0. So I'm able to have a 0 answer. Zeros are great because it makes it very easy to check. So I'm going to start with my original equation. I have a parentheses in my original, so I need to have parentheses in my check. It changes the order if you don't, or the numbers if you don't. Oops, I'm not having good luck here. Okay, so instead of working them again, I'm just going to replace those x's with zeros. So 3, and I've got a 0 plus 4 is equal to negative 2, and then a 0 minus 6. And again, you can use calculators to simplify, but this is, because I have all my numbers, I don't need to do the distributing again. I can just do order of operations. So this is 4 times 3, which is 12. And over here, I've got a negative 2 and a negative 6, which is a positive 12. So it works out as long as I'm putting everything in correctly. Okay, so this problem right here is just super long, and you've got to do some simplification before you can solve it. So when you're working on the same side of the equal sign, you don't change your sign. So here, a negative 3x and a positive 6x, simply subtract and give me a 3x. The negative 6 and the positive 10, simply subtract and give me a positive 4. And again, you can use your calculator to help you simplify. On this side, a 5x and a 2x is a 7x plus 12. And now that I've simplified it down, I'm able to move things. So I'm going to move my 3x. I'm going to subtract 3x. Again, you could move 7 if you really wanted to. It doesn't matter. So I have 4 is equal to 4x plus 12. And then at this point, I need to move this 12. So I'm going to subtract this 12 from both sides. I have 4x. And 4 minus 12 is a negative 8. And then I can divide by 4. Running out of room. So x is equal to a negative 2. Okay? So when I do my check, I'm going to start up here. I'm going to just replace all of my x's with negative 2's. So I'll change colors since it's starting to get scrambled. So I've got negative 3x plus 6x minus 6 plus 10 equals 5x plus 2x plus 12. Ugh, squeeze that in there. So now it's negative 3 times negative 2 plus 6 times negative 2 minus 6 plus 10 equals 5 times negative 2 plus 2 times negative 2 plus 12. Okay, so I ran out of room there, but you get the idea. So this is going to give me a positive 6, and this is going to give me a negative 12, and then this is still going to give me a positive 4, and then on this side I have negative 10, I have negative 4, and positive 12. Okay, so I'm kind of working away from that. So I've got 6 minus 12 is a negative 6, plus 4 is going to give me a negative 2. Over here, negative 10 and negative 4 is a negative 14, plus 12 is going to give me a negative 2. So again, this one would be a great one to use your calculator on because I made a big mess and a scribble of it, but you got the idea. Okay, so this one's working with fractions, and we're also going to have some on your homework and labs that deal with fractions and decimals. You're going to do the exact same operations. You know, if it's a decimal, treat it like a whole number, just move it back and forth. If it's a fraction, you're going to treat it just like we did before. So my idea is to get the half by itself, the y by itself. So I'm going to subtract half from both sides. Now this would be a great time to use your calculator. So that half cancels, I have y. And then I have 4/5 minus 1/2. So I can use my calculator to calculate 4/5 minus 1/2, or I can change them over into, common denominators. So this one would be 10. So I'd multiply by 2 by 2. So I have 8/10. And here, this is if I multiply each by 5. I've got 5/10. So 8/10 minus 5/10 is 3/10. So that would be my solution. And again, you get to it really quickly if you use a calculator. You can check it. 1/2 plus y is equal to 4/5. So it's 1/2 plus 3/10 is equal to 4/5, right? So these two need to be added together, and you can use your calculator to do that. You can convert them over. So this is 5/10 plus 3/10 is 8/10. And when I reduce that by 2, I have 4/5, which equals 4/5. So if it were me, I would use my calculator to do some of the functions to make it faster and to make sure that I've reduced everything.